Morning, everybody, and welcome to the second annual AWS Summit in Chicago. My name is Matt Wood, and I'm delighted to join you here for a keynote where we'll have some customer speakers telling you about how they're using AWS, and who knows, some new news as well. We have over 7,000 people registered to attend this event. We have over 8,000 joining us on the live stream as well, watching on aws.amazon.com. And I'm delighted to be able to say that we have 54 deep technical sessions across the AWS family today. And we have over 70 different expo partners that are building out their business on AWS for you to go and interview and talk to at the expo after the keynote. So without further ado, we've got a lot to get through. Let's get started. When I joined Amazon Web Services in 2010, I was based over in Europe. And you basically only had to say the word cloud computing before I would jump on a flight and come and talk to you. And this was one of the first clouds that I would have probably showed you. You can see our beautiful color scheme, blue and yellow here. And this outlines from 2010 the benefits of cloud computing. And these seem very familiar to us all now, the benefits of moving from a CapEx to an OpEx model, the ability to be able to pay as you go and only pay for what you use, the ability to have elastic capacity and scale up when you need it and back down when you no longer need it, to be able to get a faster time to market without worrying about the undifferentiated heavy lifting associated with building out infrastructure. And if you fast forward just 6 years, it's pretty amazing at the transformation that's taking place. AWS in 2016 looks like a very different beast. We're growing at 70% year on year, and today we have over 1 million active customers per month on the platform. And we define an active customer by somebody that is external to Amazon.com that is actually using the platform. These aren't just accounts that are sitting there not being used. These are customers that are really using the platform month in, month out. Every year, Gartner publishes a Magic Quadrant, which shows how all the cloud computing infrastructure as a service landscape is evolving. And in the last coverage of the Gartner Magic Quadrant, they reported that today AWS has 10 times the compute capacity in use of the 14 others in the Magic Quadrant combined. So we're growing pretty quickly, and we're now at a $10 billion run rate as a business, and we're actually the fastest technology company to reach that landmark in just a little under 10 years. So AWS today looks very different from AWS in 2010 when I joined. And it has become the infrastructure technology platform of choice for a large number of organizations. When we started AWS, we assumed that the idea of a move to operational model and the elasticity of the cloud would be most relevant to startups. And for sure, we have a large number of startups that have grown very successful on AWS today, whether it's Pinterest, Airbnb, Stripe, Slack, Domo, Periscope, and a number of others that you've probably heard of on this slide. But what we saw was it wasn't just the move from a capital to an operational model that was beneficial. Startups love the ability to be able to move quickly and the agility that the cloud was giving them. And it turns out that that's just as relevant to enterprise customers. And so today, whether it's oil and gas, healthcare, manufacturing, financial services, retail, or media, we have a large number of enterprise customers that are running material, meaningful production workloads up in the cloud. To support those customers, we also have a large number of partners, and we also have a large number of public sector customers. Today, our public sector business is pretty healthy. We have 2,000 government agencies running on AWS today. We have over 5,000 academic institutions and 18,000 nonprofits up and running on AWS. And you may see your alma mater on the slide behind me. In addition to that, we have thousands of system integrators from the large global system integrators like Accenture, Booz Allen, Cognizant, all the way through to the cloud-native, born-in-the-cloud startups such as Second Watch. And a large number of ISVs building out software on AWS, all the way from Adobe, Acquia, Atlassian, Autodesk, Splunk, and Infor. And what we see across all of these different usages, all of these millions of different customers running on the platform every single month, is we see innovation across virtually every industry unleashed as a result of using AWS. So whether it's Bristol Myers Squibb, who are able to use AWS to drive a dramatic reduction in the time it took to run their clinical trials, a 98% reduction. And that means that clinical trials move more efficiently and get drugs to market more quickly. Or whether it's in gaming with Supercell, where they were recently launched a new game, Clash Royale, their most recent and successful launch to date. It's a great game. If you haven't played it, you can download it after the keynote. And they're able to scale to millions of concurrent players right at launch. Or MLB, who installed missile tracking technology in all of their Major League Baseball stadiums in order to be able to track the ball and the players in real time, generating and receiving petabytes of data every season and analyzing that data to give real-time statistics on whether someone should have slid into first base or not. Or whether it's FINRA, who are able to replay billions of trades instantly on AWS. So across virtually every industry, we're seeing tremendous amounts of innovation. So what I thought I'd do in the keynote this morning was just run you through some patterns, some trends that we're seeing for customers in how they're innovating. And they kind of fall into three kind of mega trends, and we'll go on from there. So the first mega trend, and what is driving a huge amount of innovation across these different industries, is the ability to be able to remove constraints. Information inside an organization is its lifeblood, and being able to move and use that information in a meaningful way drives the organization. And the more easily and the more quickly you can access and use that information, the more quickly you can use it to make decisions and take feedback on those decisions and feed that back into your process. Now, technology has always held the promise of accelerating that process, of moving information and collaborating around information and getting more real value out of that information almost from day one. We even have a term for it, information technology. However, over time, in the old world, where we are building large data centers and huge physical networks, and installing servers and procuring servers and configuring servers, to technology which was designed to accelerate that work became a constraint in and of itself. And so one of the trends that we see with customers as they use AWS is they are starting to unbound the creativity of their developers and their teams through the use of technology. Technology is becoming the accelerant that it was promised to be instead of the constraint that it had become in large physical infrastructure. And at AWS, we spent the last 10 years building out a pretty robust, deep, broad platform of infrastructure technology services. At the base level, we have our physical infrastructure. This consists of 12 different geographic regions around the world, and we think of regions perhaps a little bit differently to the traditional model. A region for us is a collection of what we call availability zones, and availability zones are one or more individual data centers which are redundantly powered, redundantly connected, and a minimum distance apart. So those availability zones are coupled together to build highly available fault-tolerant systems within a region. We have 12 regions today, and we have 5 more coming online this year in Ohio, Montreal, UK, India, and Ningxia in China. We also have 54 different POP networks on our edge network. We have a large global network which connects all these regions together for faster connectivity. And we also have GovCloud, which allows you to run ITAR-compliant workloads on AWS. And built on top of this are our core infrastructure services that I'm sure many of you are familiar with. The compute, storage, databases, networking, and monitoring that make up the foundation of many applications running on AWS. Alongside that, we spent time building out and investing in a large number of platform services based on analytics, application and developer acceleration, mobile services, DevOps, and a new IoT platform that we announced at the end of last year. We've also worked on a collection of enterprise services to help enterprises migrate and adopt the cloud more easily. So whether it's working with migration, building out hybrid applications, running virtual desktops, using corporate email with Workmail, or collaboration with WorkDocs, enterprises are using more and more of these services to be able to move more quickly. And of course, the core of all of this, the central thing, the number one thing that we spend our time thinking about really relates to security and compliance. So we spend a lot of time thinking about identity and building out identity and access control services. We think a lot about key management and how you can control your own keys using the key management service or using hardware HSMs. We also have configuration and compliance checks, and we have built-in auditing so you can see who did what to when, to which resource on the AWS cloud. And finally, we have a very successful marketplace, which allows you to pull down products, open source, and third-party from sellers. And we have over 200 million hours per month of EC2 time being run on marketplace products. So in addition to this very broad set of services, each one of these little boxes represents a deep set of functionality. So for compute, we don't just have 1 or 2 instance types. We have a broad selection of instance types for general purpose computing, high performance computing, high memory computing, GPUs, high I/O computing, even dedicated instances for regulated workloads. And we actually have twice as many as the nearest competitor for compute instances. The same is true for databases. Today, we have 6 different database engines available on the relational database service: Aurora, Postgres, MySQL, MariaDB, and the traditional Oracle and SQL Server databases. And these databases aren't just running on RDS, they also run in multi-AZ configurations. So you can split your database for higher availability. If we take a look at identity and access control, we have a very, very deep and fine-grained set of identity and access controls, which allow you to not just specify a high-level role, but get really fine-grained and granular on who can do what to which resource. So you can say that a specific individual inside your organization, Steve, can add a table to a specific RDS instance at a particular time only from within the corporate network. You can get very fine-grained on how you control these resources. So I want to switch quickly back to storage. Storage is an area which we launched with S3 10 years ago, a large, distributed, highly available object store. And we've added to that over time to match as many workloads to the cloud as we can, based on feedback from you, our customers. So whether it's archival storage with Glacier, whether it's file systems with the Elastic File System, and the block store with the Elastic Block Store. And inside that, we have general purpose volumes for the block store, we have provisioned IOPS, and we have magnetic media. And EBS, the Elastic Block Store, is really one of the wonders of the world. And we spend a lot of time delivering on the innovation on behalf of our customers to provide latency-sensitive transactional workloads a consistent high IOPS environment to run. So these are things like databases, where they need latency-sensitive transactional workloads, typically running on solid state. So we made a lot of investments in solid state media running under the hood of the Elastic Block service. In addition to that, we started to work with provisioned IOPS and a burst model, which is great for boot volumes and dev and test and low latency interactive applications, which allow you to reach a consistent baseline of performance, but then when you need additional burst, you can just scale up for a short period of time. So we've done a lot of innovation under the hood to make this work with solid-state drives, which are specifically good for these sort of random access transactional workloads. And we asked a question not too long ago, can we innovate in the same way with magnetic media? Now, some of you might think, well, what does magnetic media have to offer? SSDs are where it's at. But actually, magnetic media and hard drives have a couple of really nice characteristics if you're building out a large-scale cloud platform. The first is they're really, really cheap, so you can buy a lot of them. The second is they have a particular characteristic for sequential reads, i.e. high-throughput reads. So we wanted to ask, can we provide a new service which would allow us to provide common sequential high-throughput performance using magnetic media? And so today, we're announcing 2 new EBS volumes, specifically built for big data workloads and throughput. The first is a throughput-optimized HDD volume called ST1. This provides up to 500 meg per second at a remarkably low cost. This is a step-level change for customers in the cost and performance of hard drives, which are still the optimal choice for block storage for big data. So up to 500 meg per second at 4.5 cents per gigabyte per month. And for data which you're accessing less frequently, we have a cold HDD volume, SC1, which provides 250 meg per second at just 2.5 cents per gigabyte per month. That's cheaper than S3. So this is excellent for big data workloads. In fact, this is the industry's best price performance for block storage for these high throughput workloads. And commonly seen in log processing, streaming data processing, specifically Apache Kafka, data analytics with MapReduce, and in fact, Elastic MapReduce will support these new block volumes straight out of the gate, data warehousing, and less frequently accessed data that'll sit in colder volumes. We've been very lucky to have some great private beta participants of these new volumes. Localytics, some of you may be familiar with, are a lifecycle engagement platform for web and mobile applications. They're used in more than 37,000 apps, and they're installed in 2.5 billion devices. Using these new volumes, Localytics saved over 50% on their monthly storage costs with reliable throughput. Or Confluence, who saw the same 50% savings through throughput without sacrificing performance. Partners are also getting in on the game with partners like Splunk, who are now able to deliver robust infrastructure monitoring and operational intelligence using these volumes. So these new volumes, we're very excited, and they'll be available from tomorrow. The second trend that we're seeing is that more and more enterprises are able to move fast without sacrificing control. In an old world, it became common to think, well, I can either, column A, move fast, or column B, I can stay secure. And this is kind of a false choice when you have the breadth of the infrastructure platform available to you that we have on AWS today. We provide the broadest set of accreditations and certifications, whether it's PCI DSS Level 3, whether it's FISMA, HIPAA workloads, ITAR compliance that I talked about before, and record retention policies that you can apply to Glacier with Glacier Vault Lock. In addition to this, we have a broad set of services to secure your applications running in the cloud. Whether you're using networking, using the virtual private cloud, or the web application firewall, which will keep the bad guys away from your web app. Or identity with identity and access management, where we have not just identity and access in the cloud, but also federated identity with SAML. We have encryption services with the key management service, which allows you to take your keys and run them in a managed environment. We have cloud hardware security modules that give you even more control over access to the keys. And we have a new encryption SDK, which allows you to control the encryption of your data within your Java applications. In addition to that, we have a wide range of compliance services. So we have a service catalog, which allows you to control who in your organization can access what applications. We have CloudTrail, which will provide continuous auditing of all the API calls that come into your AWS environment. We have config and config rules, which allows you to specify a configuration of your environment and then get notifications and take automated remediated action when a change happens to that environment. And we have a service called Inspector, which allows you to build best practices inside your continuous delivery of your applications from a security perspective. So we announced Inspector in preview at reInvent, our developer conference in October last year, and today we're making it generally available for all customers. So let's take a quick look at how to detect and remediate security issues with Amazon Inspector. So first of all, Inspector will sit next to your application, and it will assess the network, the VMs, the operating system, and all the application configurations sitting alongside your application. And it will compare those against a built-in content library of common security standards and vulnerabilities. Once you have that, we'll run detailed reports and provide you a dashboard of how your application is performing against these best practices. And, of course, we'll audit the tests that were run and whether you are in or out of compliance with full audit trails inside CloudTrail. So that's available for all customers tomorrow. And again, we've got a lot of customers and partners that are already integrating Inspector results into their applications for better visualization. So in the old world, where you had to choose between moving fast or staying secure, today you can not only build application and environment QA into your process, but you can build best practice and monitoring and evaluation into your continuous delivery model. And what that means is you can now move fast and stay secure. And so this is really important to get the maximum value of your applications and the maximum value of AWS. And to talk a little bit more about that, I'd now like to welcome to the stage Ben Wilson, the CTO of GE Oil and Gas. Thanks.
Thanks, Matt. That's one heck of a pocket square. I'm kind of wishing I had one. My name is Ben Wilson, and I work for GE. GE is a really big place. We have about $120 billion in revenue, about 400,000 employees. We operate in almost every country in the world, and we operate in industries like aviation, healthcare, transportation, power and water, renewables, and my favorite, oil and gas. And that's where I work. As part of GE Oil and Gas, we believe energy is valuable, and the world's going to need more. The world's going to need more because populations are growing to 9 billion, because urban centers are also growing. As part of our role in that energy transformation is we build products that help to extract, transform, and refine oil and gas. So we can be part of the energy train that helps to power things like data centers for AWS, networks, and probably the most important thing in my world is laptops for developers. Let's see, did it go? There we go. Today, in the oil and gas industry, you can imagine we're operating in an uncertain world. In this uncertain world, oil prices have plummeted, gas prices have gone down, so hopefully you guys all have a few extra bucks in our pocket. But the interesting thing is we see people pulling back from the oil and gas industry. At GE, we're doubling down on the oil and gas industry. The reason is we're going to use technologies from our other industries to help us be more successful in the oil and gas industry. A couple of examples. One is if you think about a rig that's out in the Gulf of Mexico and it needs power, we build equipment for that. We leverage capabilities and technologies from our jet engines in the aviation business to make it more efficient and effective for our customers. Another example is LNG facilities where we transform natural gas into liquefied natural gas, and we use technology for compression from our power generation business. And one that's probably not so obvious is MRIs from our healthcare business. So we actually have these things called pigs that go down a pipeline and do inspections for integrity. And what they do is they try to figure out, hey, is there a crack starting to form here? How is this weld going to work out? Is there any corrosion? We use that MRI technology inside those pigs. GE is turning into the first digital industrial organization in the world. We're putting sensors on all of our products. We're pulling off terabytes and sometimes petabytes worth of data. And in doing that, we're using that to be able to make our products better and also make our customers more successful. The real reason I'm here today is to talk about our cloud transformation in GE Oil and Gas. We've moved about 350 applications to the AWS cloud to date. And with those types of applications, people oftentimes look at the cloud and they say, hey, an application has hundreds of thousands or millions of users. That's not what we have. We have applications that have tens of users or maybe 100 users. And that's a very different profile. With that different profile, we have to make sure we understand what's going on with every single one of them. We have to tag, monitor, measure, and automate every one of them and start to create patterns that allow us to make those reusable. Without that, we would never be successful. A couple of examples of applications we have in the cloud. SAP Hybris, which is our storefront on the web to be able to sell products to our customers. Get Paid, which is a great application for us because we have a lot of invoices coming in and we create a single invoice out of that. Really important in the oil and gas industry when things aren't going so well. WordPress we moved in, so our 90% cost reduction there. But a really interesting one is called Epsilon. Has 750 terabytes worth of data that we have to do analysis against. And we've moved that to AWS too. Overall, our journey is to get 500 apps into AWS, and we believe that will provide us enough apps that will really make us successful in the long run. But one of the things that people want to talk about the most is, what are the real benefits? So you move the apps, so what happened? What we've seen is a 52% total cost of ownership reduction. Now, a lot of people go, oh, that must be on storage or it must be on EC2 instances. And although in some cases that is true, we were a highly virtualized environment already, so we saw some benefit there, but not so much. Where we saw the greatest benefit is when we started using tools inside AWS that made a difference. If you think about things like Aurora as an example, it's a metered database now. So we tossed out the databases we were using, started using Aurora, and you think back on that last slide about us tagging and monitoring all those apps, what we were able to do is leverage a whole bunch of data that comes out of Trusted Advisor and CloudWatch that allows us to be able to know when our applications are being used by users and not. And you can imagine 10 users, 50 users, 100 users, odds are they're not using them at night. They're probably just using it for about 8 or 10 hours a day. With that, we're able to shut them down and then bring them back up when it's needed with things like Elastic Beanstalk, driving down our costs and being able to make it a more resilient and durable application. A really important point. The next thing I want to talk about is the AWS Snowball. It's a new tool from AWS. It's a pretty nice tool. We like it. We're using it with our Epsilon project where we're moving 750 terabytes. And we found this to be a good tool. We've moved our first 50 terabytes. It took us roughly 2 weeks. We estimated it was going to take us 100 days or more to go do that. And you can imagine we have another 700 terabytes or 14 snowballs that we still need to move. We find it fast, efficient, and it works quite well, at least for the particular situation we're in. The other thing people ask me about quite often is what's next for us? You've moved 350 apps. You're seeing a total cost reduction of 52%, what's really next? Well, we're moving all of our apps into the cloud, right? And for us inside AWS, we're going to start moving our engineering apps into the cloud because we want to provide a differentiated user experience for our engineers. So if you think about it, our engineers are in Florence, Italy, in Aberdeen, Houston, Singapore, Shanghai, Perth. They're all over the world. They have 100 megabyte files that they're moving back and forth. And with those files, it becomes very challenging to be able to make that work. If we can put it all in AWS, use the 10 gigabit backplane to be able to move the data, and then use things like desktop as a service to be able to provide a differentiated user experience, it would be extremely helpful. And it would really help us drive down costs, and most importantly, help to eliminate data centers. And that's a really important piece for us. So that's my last slide. Thank you very much for your attention. Have a great conference.
Great. Thank you, Ben. And I just love these large, aggressive moves to the cloud. It's great. So another megatrend that we see is the ability for organizations to be able to automate as much of their development and infrastructure as possible. With AWS, everything is just an API call away, including a service which generates APIs. And if you're not familiar, if you're new to AWS, which we have some new customers here today, this is a very common continuous delivery model, where you spin up your environment, you QA that environment using tools like config and inspector that we just talked about. Then you deploy your app inside that environment and go ahead and build, develop, test, and QA that app, spinning this cycle, this application life cycle, as quickly as you can. And Elastic Beanstalk is a service that we have which automates all of this for you whenever you need it. All you need to do is simply upload your code, and Elastic Beanstalk sets up the environment, QAs the environment, deploys the app, and all you have to worry about is pushing new versions of the app up into Elastic Beanstalk. It's a great way to get up and running with AWS quickly and then deliver at scale. And Elastic Beanstalk applications have a couple of different components. They have your app, of course, running in Java or .NET, PHP, Node, Python, Ruby, Go, whatever you like. You can also deploy Docker containers and run multi-container environments on Elastic Beanstalk. And these applications and containers are then delivered onto a platform. And this is the ARMY, so the base operating system of your platform, and the app server, the Tomcats, the IIS, the passengers, the pumas, the glassfishes, all sorts of animals that sit onside the platform. And then over here on the right-hand side, we have all the AWS infrastructure, which Elastic Beanstalk is going to manage on your behalf. The instances, the auto-scaling groups that allow you to scale up and down and recover gracefully from failure, load balancing to get the networking all sorted across this distributed application, and health checks to manage the health of your application and take automated remediated action in the event of a problem. Now, over here on the left-hand side, that's typically the developer's responsibility. And over here on the right-hand side, that's kind of Elastic Beanstalk's bread and butter. But over here in the middle with the platform, maintaining and operating and keeping that platform up to date has become a kind of shared responsibility. So when the Amazon Linux version increments, it's been the responsibility of our developers to go install that against their application. And we want to make it as easy as possible for developers to move quickly and stay secure. And so we asked the question, can we remove more of the maintenance burden for web applications? Can we make it easier to manage the platform that your applications sit on top of, in addition to the availability and the scale of your application that Elastic Beanstalk is known for? And so today we're adding an update for Elastic Beanstalk called Platform Updates, which allow you to safely and automatically keep your web application up to date. And this will be available for all customers tomorrow. So managed updates for Elastic Beanstalk allow you to keep your application platform up to date. All the operating system and the IIS servers and the web servers and the application containers, all of that sits on the platform. And as soon as an update is detected, we'll make sure that the application is deployed against the new up-to-date application without you having to worry about it. You stay in control of platform updates. So a little bit like you can do with RDS, you can schedule maintenance windows where this maintenance will take place. And then Elastic Beanstalk will safely perform the updates whilst maintaining availability of your application. And the way it does this is kind of cool. Elastic Beanstalk will perform an automated blue-green deployment. So here we have a very basic architecture of an Elastic Beanstalk application where we have requests coming into the load balancer, which then gets balanced across a number of nodes. These instances are running on EC2, and if one fails, then another one automatically gets replaced inside the group, and you can add or remove capacity as your application needs to scale automatically. So when a new platform becomes available, Elastic Beanstalk will spin up a blue-green deployment. It'll keep the traffic pointed from the load balancer to the blue auto-scaling group, and it'll deploy the new version of the platform and the application into the green auto-scaling group. And it'll run tests against that application to make sure that everything is checked out before any traffic gets routed to it. So after a single instance is spun up and checks out, it'll then populate the auto-scaling group with the same number of instances as the previous auto-scaling group. And when all the tests there check out, and only when the service is absolutely happy, it'll swap the two over. It'll start to route traffic into the green new version of the platform, and the old version will disappear. So this is an immutable way of deploying and managing applications. You can get rid of the old version and instantiate a new version completely immutably. So this is a new version, new feature for Elastic Beanstalk available tomorrow. Another trend that we see is customers moving to simplify relentlessly their development and their operations. And S3, the simple storage service, was one of the first internet-scale applications, the internet-scale building blocks, which allowed developers to focus more on their code and their application without having to worry about procuring and provisioning storage. And when we built S3, it had 5 very simple, seemingly, characteristics. It had to be extremely simple and easy to use. It had to be scalable. It had to be delivered at low cost. It had to be reliable, and it had to be low latency. And S3 became the first internet-scale component for applications which were growing quickly. And these building blocks for internet-scale applications really took off, and this is the foundation for a lot of the innovation that we saw from customers in the early days of AWS. And right around the time when S3 was really taking off with customers, we asked a question. Can we apply the same approach? Can we take those same characteristics of simplicity and scale and low cost and apply them to other application components? And this was the origin of a functional computing platform that we call AWS Lambda. And AWS Lambda has the exact same characteristics as S3. It's designed to deliver a serverless compute platform, which is simple and easy to use, extremely scalable, low cost, reliable, and low latency. And the way that it works is a little bit like S3. All you have to do is just deploy your code into Lambda. You'll get sub-second metering when those functions run, and there are no servers at all to procure, provision, or manage. And we announced this 2 years ago, and the adoption of Lambda has been remarkable. We have a number of customers that are running Lambda in production today across 4 kind of large buckets of usage, which I'll talk about a little bit. But ad roll is a really good example. This is an ad retargeting platform which stores over 300 terabytes of new compressed data in S3 every month. And as new data gets added to S3, Lambda functions respond automatically at whatever scale they need, process that data so that their downstream machine learning teams can take advantage of it. And combining both S3 and Lambda together means that you can run entire web applications without having to worry about any servers. And when it comes down to it, no server is easier to manage than no server at all. So Bustle is a really good example of this. Bustle started experimenting with Lambda for real-time data processing using Kinesis. But they quickly found the benefits extended into running their core application themselves. And they moved into this common environment where you have the HTML of your application running in S3. You call API gateway, which then calls Lambda on the back end to implement your application features as small microservices. So whether it's search or recommendations or common CRUD updates. And then they talk typically to DynamoDB on the back end. And the cost of running this is remarkably small, and you can scale and spend no time at all thinking about what happens when you need to scale to millions of different users. Another really common usage is serverless data processing. So I love this example from FireEye. FireEye is an intrusion detection system and sits on top of Lambda. And what they do is they have re-implemented MapReduce effectively inside Lambda. So they have this cascading calls of Lambda functions calling Lambda functions working on data in S3, which then maps the data together, reduces it back to get a result. And they used to do this using Elasticsearch, running on EC2, but they found the same exact performance, if not better, by moving to Lambda, and they reduce the cost by 80% by moving off Elasticsearch running on EC2. So this is a really good use case for big data processing without having to manage servers at all. Another common use case we see is in the Internet of Things. Some of you may recognize this from our cousins over at Amazon Retail. This is Amazon Echo. And Amazon Echo responds to your voice. You can say, hey, Alexa, play music. In addition to that, Echo provides a development platform where you can extend Alexa's skills using Lambda. So all you have to do to add skills to Alexa is to be able to write a single Lambda function, plug it into Alexa and get it certified, and then you can ask Alexa anything that you want. And because Lambda will scale and you don't have to worry about the servers under the hood, and you don't have to worry about the operations, you can just write that single function in JavaScript or Java or Python, and it will respond from your Echo device. So the platform that Alexa provides with the Alexa Skills Kit runs on top of Lambda. It's very easy to use just from the website. The fourth major area that customers are using Lambda for is to provide the connective tissue of their AWS environments. So some of you may be familiar with a new service which we launched a couple months ago called CloudWatch Events. This gives you an event stream of everything that's taking place inside your AWS infrastructure and then allows you to respond quickly and automatically using Lambda functions. So Capital One are using CloudWatch Events and Lambda to build higher levels of compliance inside their applications. And if you want to know a little bit more about that, they're speaking in the Protecting Your Data in AWS session this afternoon. We also have lifecycle hooks for Elastic load balancing. So when something changes inside an auto-scaling group, you can get a notification which Lambda will respond to. Config rules, you can extend the rules inside the configuration monitoring using Lambda and then remediate or notify if your application falls out of compliance. And you can also run scheduled jobs, a lot like cron, using CloudWatch Events and Lambda. And a lot of customers in the ecosystem, specifically Splunk, have really embraced Lambda to provide more functionality inside their applications. So those four areas have really driven Lambda to become the connective tissue and become the default way of building serverless applications on AWS. The third major building block for internet scale applications is Amazon DynamoDB. DynamoDB is, again, one of the wonders of the world. And it has the exact same characteristics, you may be seeing a pattern here, of simplicity, scalability, low cost, reliability, and low latency that S3 and Lambda were designed with in mind. And we announced DynamoDB and launched it about 4 years ago, and the uptick and the success of customers using it has been astonishing. So here are just a few examples. Redfin with 5 billion items. We have Expedia that are running 200 million messages processed every single day. Mapbox that have over 200 million users running on top of DynamoDB. And I'd like to introduce our next speaker to talk a little bit about how they're using DynamoDB. Please welcome Karen Tsai from Duolingo. Thanks.
Hello, everyone. I hope you're having a great summit so far. My name is Karen Tsai, and I'm a senior software engineer at Duolingo. We're a language learning startup located nearby in Pittsburgh, Pennsylvania. Duolingo started as a project out of Carnegie Mellon University in 2012. Duolingo started as a language learning startup that wanted to enable people around the world to learn a language for free. We want to provide a quality language education for free, forever, to anyone who wants to learn a language. This mission is especially important to us because we believe that language education is especially important in countries where learning English may be a stepping stone to better job and educational opportunities. So far, we've been incredibly fortunate as a startup. We've been named Apple's iPhone App of the Year, Google's Best of the Best for 2 years, and TechCrunch's Best Educational Startup in 2014. The journey has been incredible, and today I'd like to take a few minutes to talk about how AWS has helped us get to where we are today. Back when I joined Duolingo, about 3.5 years ago, there were about 15 people, 2 dogs, and not a lot of experience scaling a product from scratch. We were a team that was passionate about making an impact and about coding, but had very little knowledge about DevOps, or what a production-level infrastructure really looked like. What we did know is that we would need to store and retrieve a lot of data. This is because at Duolingo, we believe in a scientific, data-driven approach to education. It's not enough for our app to be free. It also needs to be effective. We want to personalize education, gearing our teaching method to each individual user of our application. Let me explain a little bit how we want to do this. On Duolingo, we teach you a language by giving you language exercises to complete. This could be translating a sentence into a language you're learning, or being asked to recall vocabulary. Every time a user interacts with our application, we store information about that user and how they answered that question so that we can detect when a user may be struggling with remembering a grammatical concept or recalling vocabulary. We then use this in order to provide a personalized experience for the user. How much data is this? Well, we need to store this information for every single exercise done on this application. And to get an idea of the scale of this data, here's a fun fact. More people are learning a language on Duolingo than the entire US school system. To get an idea of just how these numbers are broken down, we have about 80 different language courses across an international audience. There are 18 million monthly active users doing 6 billion exercises per month. And perhaps most remarkably, with a team of less than 70 people reaching over 120 million users, Duolingo only needs to dedicate 2 of its staff to DevOps, thanks to AWS. So here is how AWS has helped us scale. We use a lot of AWS web services. We use CloudWatch for monitoring and alarms to make sure that our app is always up and running and that we can address problems quickly. We use Elasticache to reduce latency, and we use it as a cache layer on top of our more permanent data stores. We use EC2 to host all of our web servers, S3 for hosting larger pieces of information, such as images, and we use CloudFront as a CDN on top of that. We use RDS with MySQL, and SQS as communication between microservices. And finally, our superstar service has been DynamoDB. Matt mentioned that Dynamo is a wonder of the world, and we agree. DynamoDB is the only service that has kept up with our demands. As I mentioned earlier, we want to personalize language education, and that means storing a lot of data about each of our users. DynamoDB is the service we use to store information about a user's vocabulary knowledge. We have over 31 billion items in our largest DynamoDB table, and that table executes over 24,000 read units per second and over 3,000 write units per second without breaking a sweat. As a bonus, DynamoDB also scales up when we have traffic peaks and also scales down off-peak to save us a bit of money. We're incredibly happy so far with how AWS has saved us so much time in all of our needs. We look forward to continuing using future AWS services. We want to move more data to DynamoDB to reduce latency. We also want to leverage Elastic Beanstalk for deploying microservices and move over to Redshift for data analytics. And finally, we're looking into using Lambda for some of our computing needs. As a small company with big goals, we're incredibly grateful for all of the work that AWS has saved us. AWS has enabled us to focus on our mission, which is free language education for the world. Thank you.
Thank you very much. Good job. A small company with big goals. I just love that story. So we've talked about S3 and Lambda and DynamoDB as being the backbone for broad serverless architectures. And they sit alongside a range of supporting services such as API Gateway, the simple email service, the simple notification service, the simple queue service, our monitoring tools with CloudWatch and CloudWatch events, and all of our encryption tools to build out applications with services, not with servers, using this serverless platform. And it's great to hear the story from Duolingo about how they're doing that. So the next mega trend, changing color here, is that a lot of our customers are now able to, just as we heard from Duolingo, observe the data and the way that their customers are using their applications, and then quickly iterate and provide better experiences based on that information, and to make disparate connections that they may not have made using data analytics. So more and more of our customers that are driving these kind of inventive workloads are increasingly being driven by the data that their applications are being created. And to enable that, we've invested in a core set of components for big data workloads. We talked about S3, we talked about DynamoDB and RDS for high-performance databases. We talked a little bit about analytics clusters. We're using Hadoop on EMR and Spark on EMR, particularly with those new, fast, high-throughput EBS volumes that we announced today. We added an Elasticsearch service late last year. We have a streaming data service called Amazon Kinesis. We also provide predictive analytics through machine learning, and we have our data warehouse, Redshift, that we've talked a little bit about as well today. In order to be able to use all of these tools, the analytics and the data warehousing to look backwards in time, to be able to evaluate what's happening in real time using streaming data and Kinesis, or to be able to predict what might happen in the future using predictive analytics and machine learning, you typically need to be able to move your data into the cloud. And there are a number of different ways to do that. Our customers are doing this. The first is a lot of our enterprise customers are choosing persistent connectivity through Direct Connect. This provides you consistent direct connections directly into our data centers connected with your data centers. So you get a consistent level of connectivity directly into the AWS regions. But in addition to that, there's a spectrum of how our customers are moving data, whether it's small amounts of data moving frequently, medium-sized amounts of data moving often, or huge data amounts moving less frequently. And I talked a little bit about Kinesis and using small and frequent data. So Amazon Kinesis is our real-time streaming data platform. It's a family of 3 different services, 2 of which are available today, 1 of which will be available later this year. The first is Kinesis Streams, which allows you to build custom applications which run on EC2 to collect and analyze streaming data at virtually any scale. In addition to that, and based on your feedback, we enhanced Kinesis with a new product called Kinesis Firehose. Kinesis Firehose has a dramatically simplified API to allow you to just put data into the stream, and then you can configure your Firehose to pipe that data into S3 or Redshift. So you can easily load streaming data directly into AWS. And today we're expanding Firehose with support for Elasticsearch. Finally, we have Kinesis Analytics. Kinesis Analytics allows you to run standard SQL queries over the streaming data that are coming in through your Kinesis streams, and that'll be available later in the year. So that's small data which is moving frequently. But at the other end of the spectrum, over on the right-hand side, we have huge amounts of data that typically needs to move less frequently. And in order to be able to enable this, you should never underestimate the bandwidth of a UPS truck. And at reInvent last year, we announced a new device called Snowball, which is a petabyte-scale data transportation service using a new custom-designed device. And I just happen to have one here. It's down here behind the podium. Here it is. This is a Snowball. I can bring it up on the screen here. So you can see it's got a ruggedized, delightful shade of gray. It's rainproof and dustproof. It's secure, and I'll tell you a little bit about how we manage the encryption. It's got everything you need inside this box, which has been tested to about 8.5 Gs, to be able to connect to your data center and load data in. So at this end, if I flip up the flap here, you can see that we have an e-ink display. So we have a Kindle in there, basically, which automatically is configured to ship to your address. And then as soon as you start loading data onto it, it automatically swaps so that it gets shipped back to the Amazon headquarters for Snowball. And this is really important because it's hidden behind this flap, because sometimes labels come off. But inside here, we have an e-ink display, which is low power, and always provides barcodes to let us know where it's going. And you can see we really did ship this one using the service today. It's got the address of the AWS booth at the Chicago Summit. And on the back side here, we have all the cables that you need to be able to connect up. Up here, we have power, and we have networking. You just plug them in, load in your data, and away you go. So I'll just pop this back down here for now. If you want to take a closer look, we have one at the AWS booth. And the way that this works is you just make the request for a Snowball device from the console, and you load your data in. We ship you the Snowball, you plug it in, you load your data in, and the keys are managed off the device. So the data is encrypted on the device, but the keys themselves are stored inside the key management service. And this provides end-to-end custody of the data. We receive the device and then load the data set into AWS. So this is perfect for large customer data sets which you want to move as quickly as possible. And you don't just have to use one of these. If you have 10 Snowballs connected to your networking DMZ, that's the equivalent of a throughput of about 100 gig network connection. So this is a very effective way of moving large amounts of data into AWS. And we've seen tremendous momentum, if you'll pardon the pun, for Snowball since we announced it. So we have WWE, who have moved a few terabytes for disaster recovery purposes. All the way at the other end of the spectrum, we have Philips, who are moving petabytes of their data as part of their offering to hospitals to take patient data and store it in a secure environment. In fact, we've shipped enough Snowballs to travel around the world 30 different times, and we've loaded over 500 billion objects using Snowball since October. It's a great service. So today we're growing the Snowball. We're announcing a new 80 terabyte Snowball device that's 60% larger than it's available today. We're increasing the global awareness of the global delivery of the devices using US West in California, Dublin, and Sydney, available today. We're also adding support for GovCloud to load your data into GovCloud. And we're committing to having Snowball available in all AWS regions by the end of 2016. So that's huge, less frequent data using Snowball and some updates to the device and availability. But right here in the middle, this is often thought of as kind of the missing middle of moving data. Moving data through direct upload directly onto AWS. And we've provided tools in the past to accelerate this as much as we can through multi-part uploads. But for large files that need to move long distances, this can still be very challenging. You're always going to be limited by the speed of light. So if you're moving your data between regions, if you're moving your data across continents, if your customers are a long way away physically from the AWS regions, or you're moving a large number of objects, this becomes more and more of a problem. And so we asked a pretty simple question. Given that we have this large edge network with CloudFront, which provides content delivery, so that is accelerated delivery down into the regions, can we use that exact same network in reverse and use the edge network, which CloudFront and Route 53, our DNS service, use, which are continually monitoring the state and routing traffic intelligently through the edge network to get as much movement through that network as possible? Can we use that in reverse? And can we speed up data in both directions, not just coming down through edge delivery, but also going back up to the cloud? And today we're announcing a new feature for S3 called S3 Transfer Acceleration. S3 Transfer Acceleration accelerates transfers to S3 using the AWS Edge Network, and it'll be available from tomorrow. So the Transfer Acceleration service provides 300% faster uploads for most use cases, and we've seen it even faster in other use cases, and I'll give you some customer examples of that. And there's no cost for using the Transfer Acceleration service if it's not faster. So in the event that the network is just the same as a normal upload, you don't pay for the Transfer Acceleration. Now, all this is great. Faster uploads are great. 4x improvement in the upload speed is great. But this is my favorite feature of the Transfer Acceleration service. To enable this, you don't need to configure protocols or endpoints or configure ports or any of that. You go into the AWS Management Console and you check this box. You check Enabled. And you get a new endpoint, and anything sent to that acceleration endpoint will be automatically accelerated through the AWS Edge Network. Click Save, and you're done. So we have some early private beta customers that have been using the S3 Transfer Acceleration feature. Frame.io are a video collaboration service. You can imagine they have people out in the field recording video, and they want to get it into the cloud so they can collaborate around it. And they saw performance improvements of about 500% in some cases. Huddle do video analysis for sports teams, and they reduced the average time it takes to ingest videos by half. And Jaunt is an amazing company. They provide cinematic virtual reality recording. They have this big sphere, which has tons of cameras on it, generates a huge amounts of video, and they want to get that back up into the cloud so they can start projecting it. And they reduce the transfer of large files from 12 hours down to 6 or even 4 using the transfer acceleration service. That's available to all customers from tomorrow. And that rounds out the full spectrum of persistent connectivity, small and frequent data moving in real time, medium and often uploads, which are going through the transfer acceleration service, and huge and less frequent updates, which are using the Snowball device. Related to this, a lot of our customers are starting to connect with their own customers wherever they happen to be. And increasingly, this means using mobile applications. And some of the best, biggest category-defining applications run on top of AWS, whether it's Netflix or Tinder or Supercell, Sega, Yelp, Airbnb, all running up on AWS. And today, developers aren't just thinking about devices. They're thinking about the device backend. So there's a duality to modern application development in mobile, which is the mobile experience, which has to be great, and then the back-end experience, which has to provide the collaboration tools. And increasingly, what customers are doing is using a mobile back-end running up on AWS. So they're talking to services like DynamoDB, just as Duolingo did, S3 and RDS, to store their data and content. And they're using the AWS Mobile Analytics service to collect usage data from how their customers are using their mobile applications. And then they're communicating and engaging with their users using the simple notification push service. And increasingly, all of this is being mediated through a couple of different services on AWS. The first is Lambda. We talked a little bit about this earlier. Lambda is becoming the mobile backend of choice for a large number of mobile applications. Applications are also communicating with their backend through API Gateway. And I wanted to spend a few minutes talking about Amazon Cognito. Amazon Cognito is a hidden gem inside the AWS platform. We have over 70 different services on AWS, and Cognito has to be one of my favorites. Cognito is a specific service for web and mobile applications, which takes care of a lot of the heavy lifting of synchronizing and communicating with backends, whether it's from a mobile or a web application. So you can store and sync data using Cognito Sync. You can safeguard your AWS credentials using temporary credentials provided by the service, so you don't have to have your master credentials exposed either on the web application or in your mobile device. And you can provide guest access so that people can use your application without logging in, as well as providing support for social identity and login services. And today, we're expanding Amazon Cognito with a new feature that many of the developers have told us that they want. So many developers want to be able to sign up and sign in users with their own identity service. Using something like Login by Amazon or Facebook is great for a subset of usage, but a lot of customers also want to provide their own identity pools. But they don't want to have to build and maintain an additional identity service to be able to do that. And they don't want to have to spend all their time trying to get the security right in order to be able to do it. So today we're announcing your identity pool as a part of Amazon Cognito Identity. And the identity pool feature allows easy user management. You can allow customers to sign up and sign in with their email address or their telephone number. We have Lambda-driven workflows, so as soon as a customer signs up, you can add customized responses using Lambda to drive a notification, for example, or move data into DynamoDB. We provide automatic multi-factor authentication right out of the box, and we'll even provide email and phone number verification as part of the service. So this is a fully managed identity pool service available for Amazon Cognito, and this again will be available tomorrow. So mobile devices are just one piece of the connected devices that are moving out into the world. And I'm sure many of you have heard of the Internet of Things and the way that everything from mobile devices to washing machines to cranes to cars are becoming connected to the internet. And so to tell us a little bit more about how they're using AWS to build a connected car platform, I'd like to welcome George Philly from here. Thank you.
Good morning. Wow, what a great looking audience. Hi, thank you for allowing me to spend time with you today at this year's AWS Summit. My name is George Philly, and I am the head of the Digital Transportation Infrastructure Group, which is a smart connectivity play within a broader location cloud portfolio at here. Today, what I'd like to talk to you a little bit about is some of our cloud services, and more importantly, the relationship we have with AWS relative to our activities within vehicle automation and intelligent transportation. So, for those of you who don't know who HERE is, we're a global location technology company that bases itself on the development of automotive-grade, high-definition mapping, analytics, and location-based services that we provide to a wide variety of industries within the automotive, consumer, enterprise, and government sectors. Now, our time is short today, so I thought this slide would be a good representation of the industry-wide collaboration that's necessary to make automated driving a reality, as well as the role that our company plays to make that happen. As the world moves closer to highly automated driving, what you'll see is the need for vehicle sensor information, contextual information about what's going on the world around us, as well as real-time big data analytics. All this will require real-time data capturing, processing, and specific location information sharing on a massive scale. This is clearly important because it points to the reason why we picked AWS as our infrastructure as a solution partner in conjunction with our cloud endeavors. Now, what I'd like to talk about here with this video is an understanding of what's going on when you talk about automated driving. So automated driving is predicated on the ability to be able to understand where you're at, where you're going, and to make decisions in an automated versus a personalized way. What you can see here is a product that we have developed called the HD Live Map. This is the industry's first cloud-based mapping asset that supports connected driver assistance as well as vehicle automation. This is a cloud-based solution that's tiled. These tiles represent digital understandings of the world that are confined to 2 kilometer by 2 kilometer areas and are provided to the vehicle so that they can orientate themselves to the environment around them. Each tile represents or has 3 layers to it: an HD map, an activity layer, and an analytics layer. The HD map provides the detail of the road, such as lane markings, attributes, and even the specific geometry of the road itself. This information defines the world that the vehicle behaves in. Once the vehicle understands where it's at, it needs to continuously update itself to be able to have a very fine understanding of its location. You can see how the vehicle in this demonstration is continuously looking for different objects. Those are objects that reside in our map and are used for the triangulation or the ability for the vehicle to have a very clear understanding of its location so that it can not only operate safely, but it can do so through legal maneuvers. The next area is the activity layer. This is all about understanding the dynamic events that go on that change the nature of the road, such as weather, construction, temporary lane closures, and accidents. This information is provided as a service down to the vehicles within those tiles so that the vehicle can understand what's going on around it as well as outside the view of its onboard sensors. Finally, we have an analytics layer. This is all about analyzing human driving behavior, and it's really important from our perspective in terms of adoption. What this does is it actually allows the vehicle to drive like a human versus a machine. What we do to make this happen is, within the framework of every tile, we collect and process massive amounts of probe data and analyze it to be able to determine driving behavior profiles. whether they're aggressive, medium, or passive in nature. This information is downloaded to the vehicle and then utilized by it to not only drive safely, but allow the vehicle to drive in a manner that is conducive to what the people in the car would consider normal driving. Now, this is actually really interesting because when you look at how this works, when you start taking into account the activity layer influencing the analytics layer, you start recognizing the complexity when you start getting things like rain and snow being involved in a traditional drive, and then mapping that up against what constitutes an aggressive drive within that weather. All this information is compressed into the tiles and is sent over the air in real time with centimeters level of accuracy, and all with the support of the AWS infrastructure. Now, why did we pick AWS? Well, for one thing, it's scalability. AWS allows us to onboard new customers anywhere in the world. Their architecture also provides us with geographic proximity nodes that allows us to meet local data storage regulations, as well as to be able to meet low latency performance specifications. We also see AWS's multi-zone reliability and disaster recovery capabilities as being key to our ability to be able to meet our customers' performance requirements. And we depend on AWS for on-demand scaling to allow us to handle things like localized traffic conditions and to be able to do high-volume, large batch processing things for such features as our humanized driving. Now, AWS allows us to do a couple things. When you talk about our services, like the HD Live Map, it allows us to be able to scale our infrastructure from a size as well as a cost standpoint to the requirements of our portfolio. AWS also, and maybe most importantly, allows us to focus. We can now spend time looking at what we do best, our core competencies around cloud computing, as well as working on vehicle automation. I want to thank you for the time that you've allowed me to have here, and please enjoy your stay in Chicago. Thank you.
Thank you, George. I don't know about you, but I could watch that self-driving car video all day long. So the third megatrend that we're going to finish on today is that the companies that are innovating on top of AWS are refusing to settle for the status quo. And they're using the ability to be able to experiment quickly, scale up when they need to power the digital transformation inside their organizations. And they're able to build entirely new products that were never part of their core competency, that are completely transforming their business in very, very short periods of time. A good example is Qantas. Qantas built Huru.com, which is a hotel booking site. And they built it in just 3 months. Their page load times were 25% faster than they were expecting, despite a 1,400% increase in traffic to the web pages. Or Singapore Post, the largest carrier in Asia Pacific. They built a brand new e-commerce business from scratch in just 3 months on top of AWS, at 50% less than it would have cost them on premises. And now it accounts for roughly 30% of their total revenue. So an experiment that moved very quickly to become a core part of the business of what was already a large business. And today, the journey to AWS is an extremely well-trodden path. It starts in and moves in a couple of different phases. Phase one is typically organizations and enterprises moving development and test and building all together new applications on AWS. The second phase is moving digital, analytics, and mobile applications into AWS. The third phase is data center migration and moving mission-critical production apps before going all in on AWS. So these might happen in a slightly different order. They may move them in a slightly different way. But overall, in aggregate, this is a very common path. So it's a very well-trodden path to move an entire organization's IT infrastructure into AWS in a pretty phased way. And the destination for many enterprises is going all in. And when Netflix announced that they were moving all in on AWS a couple of years ago, many people thought it was crazy. But they've been joined today by customers like Intuit, Time, Suncorp, FINRA, Hertz, Kapinski Group, AOL, Notre Dame, Smile, NDI, Juniper, moving all of their infrastructure and going all in building on AWS. Now, some of you may be thinking, well, this all sounds great, Matt, but we've already made an existing investment in some pretty expensive data centers. So what does this mean? Well, a lot of customers are starting to use hybrid applications using their existing investment in data centers as a stepping stone in concert with AWS. A good example is Johnson & Johnson. So Johnson & Johnson have 120 different apps, which they plan to triple this year, which are seamlessly integrated with AWS and their existing on-premises environment. And they have a centralized policy environment across AWS and their on-prem environments, which they checks every 10 minutes to provide an audit of the end-to-end system. They call it the XBot. Or Comcast, which built its new interactive entertainment platform, X1, as a hybrid application that runs on-prem and on AWS. So a lot of organizations, from Dow Jones to ITV to Gartner, are building out hybrid environments as a stepping stone to get into AWS. And so as a result, we listened to your feedback and we've built a broad set of services to enable hybrid applications, and moving and integrating your existing on-premises infrastructure with AWS. Whether it's integrated networking, extending your VPN up into AWS as just an extension of your existing data center, using Direct Connect for that consistent connectivity, whether it's integrated identity with SAML integration and the identity services we provide, or integrated management using vCenter or System Center plugins to manage AWS as if they were just additional servers and virtual machines in your existing virtualized environment. We have development tools such as OpsWorks, which will deploy applications on-prem just as easily as they deploy into AWS. And we have a storage gateway, which will run as a VM inside your data center and take that data, provide it into AWS as a hot backup. And of course, we have Marketplace, which has now metered billing, which gives you a single source of billing for the applications that you're using both on-prem and on AWS. So there's a lot of services today to build these hybrid applications and hybrid clouds. And they enable organizations as large as Capital One to perform a strategic phased migration to AWS. And this is a very common pattern that we're seeing with enterprises. Versus going all in from the start, they take a strategic phased approach to identifying the applications, the data, and the databases that they want to migrate to AWS, choosing the ones that they want to migrate in a phase, and then executing on those phases. And the more aggressive they can be, the more successful we see them being on AWS. So to talk a little bit more about this, I'd like to introduce Salvador Milan from the Kellogg Company. Thanks.
Good morning, everyone. I have the great privilege of being the global IT infrastructure leader for Kellogg Company. And it's a great time to be in Kellogg today. Everything started when our founder, W.K. Kellogg, discovered toasted flakes and started a complete new industry. In 2016, we are actually celebrating our 110th birthday. We have evolved from being a cereal company to a food company with significant presence in the snacks category after the acquisition of the Kibler Company and the Pringles brand. We have also presence around the globe. The most recent example is the joint venture we have started with Toleram in Africa to expand our market in the African continent. In Kellogg, we strive to make food that people love. Everything we do springs from the foundation of our vision to enrich and delight the world through foods and brands that matter, and thus fulfilling our purpose to nourish families so they can flourish and thrive. This is also a great time to be in information technology. Technology is one of the most powerful forces shaping businesses today, and we can apply IT to unlock savings and unleash growth. Back in 2013, we decided to craft a new vision for infrastructure. That vision contained elements of agility, innovation, and cost effectiveness. At that time, I was able to see that we were spending significant amounts of money and time into projects that has as its main purpose the replacement of aging and obsolete hardware. That money and time could have devoted to other initiatives that could have had a more direct impact into the capabilities we need to win in the marketplace. So we decided to understand the potential of cloud computing. We invited Andy Jassy and some other key members from his management team to Battle Creek, Michigan, to meet with our CIO, Brian Rice, and other key members from our team. That was the beginning of our cloud journey. One of the key items that we faced at the beginning and that we decided to do very intentionally was the creation of trust among the companies. So we decided that our chief security information officers needed to be really close to each other and build a relationship of trust. We are fortunate in Kellogg to have a CISO that is really committed to secure our data wherever it is located. We also were very intentional about our people agenda. We were very clear in our communication approach, making sure that our team knew about our aggressive agenda for cloud. We provided a number of training opportunities for them. They needed to use their skills they had at the beginning, but they needed to expand those skills to be successful. And what a great response I had from them. I am really blessed to lead a team of individuals that are willing to learn new things and come to the marketplace every day to do their best. We started putting dev and test environments in AWS. You will see on the screen the number of applications from SAP that we have tried. To me, the most significant one is that we were the first company to run an SAP development environment running on HANA. After that, a great opportunity came to our table. Our SAP Asia Pacific application environment needed an upgrade, and that was a great decision point for us. We decided to host them in AWS after a careful evaluation process where basically AWS won based on the reliability and cost effectiveness that they put on the table. We had a Unix environment that relied on physical servers and an Oracle-based environment that now I am happy to share in this forum that we went live last March with 1,600 users and 5 markets running our entire SAP environment from AWS. This project has been very transparent with zero unplanned downtime. We implemented a high availability infrastructure design, and we are able to recover data to a particular point in time, leveraging 2 availability zones. So the cloud has provided a number of benefits to us. We have seen increased reliability, improved performance, and faster replication of environments. To give you an example, a replication of a 1.5 terabyte environment took 1 week in the past. Now it's taking a couple of hours. This is really kudos to the AWS professional team, S&P, which is the company that helped us with the upgrade at the application layer, and great effort from the Kellogg team in Asia Pacific and my team here in the US. So what's next for us in this journey? We have actually started the migration of our European instance. This project is going to finish in 2016. We have started the evaluation of our North American and Latin American environments. And we are actually migrating our entire digital consumer experience to AWS, and that will be done in 2017. The North American instance will require us to do SAP on HANA leveraging X1. What a great journey for us. When we started this journey, standing up a server took us 8 weeks if you consider the sourcing time. When we started with Amazon, the web services, that became 8 hours. And now, after further automation efforts, we are taking 1 hour. I am going to close my space here just telling my Kellogg team, that is, a number of them are still in this place, that I am really humbled and honored to lead a team of professionals like you. Let's continue to break barriers for our business and add value to Kellogg Company. Thank you very much.
Thank you, Salvador. It's just a great perspective from what it takes to move a large organization's IT onto AWS. And we heard a little bit there about what it takes to start to fuel a migration. Early training and certification is a really good thing to do for your organization. Getting executive alignment is a good thing to do for your organization. And where we see things most successful, we see very strong, aggressive goals being set by the senior leadership inside enterprises to migrate to AWS. And once you have that training and certification and alignment inside your organization, it's merely a matter of moving all of your data, all of your databases, and all of your applications to AWS. So we talked a little bit about data migration using Kinesis and Snowball and using S3 upload acceleration. Another phase is moving your databases. And to help with this, in November we announced the Database Migration Service. This allows you to take on-premises databases, MySQL, Postgres, Oracle, SQL Server, and automatically move them into the AWS environment so that they run on their equivalent engines running on AWS inside RDS. Not only can the Database Migration Service perform like-for-like migrations from, say, MySQL on-prem to MySQL on RDS, it also has a collection of smart tools for schema conversion. So you can look at your schema and data transformation, you can look at the database functions inside your databases, and you can migrate databases between engines. So the schema conversion takes care of the schema and the triggers and the like inside the database, and it provides guidance on usually about 70% automation of taking that data transformation and applying it to a database of a different type. So for example, you could move from your Oracle database onto Amazon Aurora, and then the Database Migration Service takes care of the actual movement of the data from one location to another. And we've seen tremendous success with customers who are using Amazon Aurora. We announced this a couple years ago, and it has become the fastest growing AWS service. Expedia, for example, have 300 million rows of data which they input each day, and around 70,000 rows per second with just a 17 millisecond average response time running on Amazon Aurora. Amazon Aurora is a MySQL-compliant database service, which is provided at 1/10 the cost of traditional database services. Not only that, but we have customers such as Thomson Publishing that are using the Database Migration Service to move off Oracle onto Amazon Aurora using the Database Migration Service, and the entire migration process was complete from Oracle to Aurora in just 4 weeks. This is a very successful service, and we're seeing customers that are able to use these services together to accelerate their migration to AWS. The fourth key component of migration is the application migration. And it often takes weeks or months just to perform a complete discovery in preparation of a cloud migration of all the applications and databases and performance evaluations and dependencies. And there's a lot of complexity in the process to determine how applications are dependent on each other and the underlying infrastructure. Now, there are some cloud migration tools out there today from Racemi or Cloud Endure or Cloud Velox. And these are typically focused on the downstream work of actually migrating the applications once you've identified them. And so we heard loud and clear from customers that they wanted an easier way to be able to identify, discover the applications that they're running and their dependencies. And so today we're announcing the availability of the AWS Application Discovery Service, which allows you to automate the discovery of data center applications and their dependencies. So with the Application Discovery Service, AWS ADS, you can automatically discover your application inventory. You can identify the applications themselves and their infrastructure dependencies on-prem. You can measure a performance baseline of those applications, and you can take that data, encrypt it with the key management service, and store it inside AWS. And then, with the help of key ISV and SI partners, such as those listed here, you can take that information and get help in migrating the physical applications onto AWS. So that is the AWS Application Discovery Service, and it'll be available in preview in the next coming weeks. So I've kind of covered the main buckets that we see from customers, the megatrends that we see in terms of simplification and removing constraints, in terms of using data to become more data-driven and responding to customers more effectively, and then not being reliant on the status quo and driving transformation through the cloud on AWS. And what I hope for you all is that you're able to consistently reinvent your IT, your processes, and your businesses round and round as quickly as possible and drive the transformation and the innovation inside your own organization. And with that, I wish you a very pleasant day. I hope the breakout sessions go well. Thank you very much.